windows have moved again. So I get to rearrange them. And one more. Okay, so there's a question. Yeah, the assignment 2 is not in the class portal. Oh, yes, I forgot. Yes, let me. Take care of that right now. I have to be careful because I've got a class right after this one. Until by the time that class is over, I've forgotten things I should be doing. Maybe I won't be able to do it. I'm getting the infamous beach ball, so I'll try a little later. Hopefully I can remember before class. I just forgot to upload it.
Professor, your audio has the quality has decreased significantly.
Yeah, I was getting, somehow my machine was overloaded. And I may have to reboot.
It just got better, I think.
Yeah, okay, let's see how it goes. Yeah, all of a sudden I was getting infamous beach ball of death on the Mac OS. And that's a bad sign. Something was consuming all my cycles. Actually, assignment 2 is there. You just have to refresh the page. Okay, let's look at null object pattern. This is one of the patterns which does not appear in the textbook with a gang of 4. I guess in background, there was in China many years ago, there was four members of the high on the Communist Party, which were tried for being against Mao. And in a famous trial, there was 4 of them. It was called they were called the Gang of 4. And when the design pattern book came out, there was 4 authors, and so the book became known as the Gang of. Well, they became known as the Gang of 4, and so you often see this text referenced as the GOF text, or GOF.
Hello,
for the gang.
Professor. I'm not able to hear you.
Yeah, I'm getting. There's also a significant delay in the video. Let me. see what I can do. Let me, okay, the video is no longer giving me delay. How's the audio?
Better?
Yeah, okay, let me know how it is. I'm not sure what's going on. The Zoom consumes almost 3 of my cores. Another core is being consumed by something else, so it's well, we'll see how it goes. So the point of the null pattern is there are times when we do null checks, right? You've got a binary tree, you're on certain nodes, you go left or right, left or right. Each time you do it, you're like, well, does the left exist or not? Is it left pointer null? If it's not null, do this. If it is null, do that, right? So the null pattern is an attempt to replace those null checks with sending a message to an object, and that object should represent the nothing that's there. So the example I use is I have a linked list, right? And so I have a linked list class, and there's a node class, and for each, and so I want just print out the list, return the list as a string, so I represent it. Yes. And so what do I have to do? Well, in my toString method, first I check to see if the head is nil or null. If it is, then return an empty string, right? Or empty parentheses. And then what I can do is, right, go through each of the nodes, get its value. But the problem is I always have to check to see whether something's null or not, right? And so we want to use a null object pattern to remove these null checks. So in this example, I'm going to have 2 different null nodes. One I'm going to put at the beginning of the list, the second one at the end of the list. And so an empty list is going to start with a head node and end with a tail node, nothing in between. So in this case, my head node is always going to point to this null head node. So it's never going to be null. So when I create the linked list, I also create a head node, and the head node also points to tail node. So my toString method, I don't have to check to see whether the head node is null. Yeah, I'm getting a kernel task which is consuming 6 cores. I have no idea why I have that. highly annoying. Hopefully it will settle down soon. It should not be doing any updates because I have that automatic updates turned off. But we're down to 3 cores now, so that should help. So back to the node. Right, so the head node is always going to be there, tail node is going to be there. So my toString method in my linked list, I don't have to check for null because when I create the linked list, that head pointer is always pointing to a null node of type head. In the head node now, I have to implement toString, and since the head node is a null node, it will never contain a value, right? And so it's just going to return the beginning start parentheses, and then it's going to ask the next node to return its toString method. The real nodes, right, for 2 and 3, their toString method, I'll put a space, and now what's currently in that node, and then again, I don't have to check for null because there's always going to be another node, right? Even the node that contains 7 is going to have a tail node after it. The tail node, it knows there's nothing after it because it represents the end of the node. So it doesn't bother to check in to see if it has a next node or not, and it just returns the end parenthesis. So far, so good. The goal here again is remove, typing again, yes, the kernel task ended and now it's starting again. Right, so right, when do you want to use it? Well, when we want something to represent nothing or do nothing, they use these fancy words, right? We want clients to know the difference between a collaborator does something and one that does nothing. What does that mean? Well, basically it means we don't want to have to check for null or nil. We want to send a message to a reference, and where normally would check for null or nil, we just send a message, and that null object then responds appropriately, does the right thing. And what is the right thing? The right thing is whatever would have done if it had said, if nil, do this. Right. So we don't have to explicitly check for some null or special value. We just say, okay, we just send a message. And since that's embedded in a null object, we can use that object in different places. When not to use it. Yeah, so in this case, the null object would be the head node and the tail node, right? Those are, in my example, those are the two null nodes, null object I'm using. Now, so one time it does not make sense to use it is when, you know, very little code uses that reference directly. So in my example, right, in the linked list is not a good place to use it in the sense of only the linked list class worries about it, and there's only going to be a few places where we're going to check for null. So it may not be a good place to use a null object, but you know, I want to pick a simple example to illustrate the point. Another one is that variable is well encapsulated, which it is in the linked list. Right, and so again, the linked list example is probably not a place you really want to use this. Advantages. Well, we're using polymorphic classes instead of checking for null. It can simplify the client code because now the client doesn't say, oh, is that thing null or not? We just send messages. We can use that null object elsewhere if appropriate. Enforcing the encapsulation of what we want to do. In that case, may cause class explosion if we've got lots of nulls in different places, and maybe in different types of null nodes. I've never seen that happen though. You know, once we've got a null object that we're using in multiple places, then we're getting the same behavior, and that may not be what we want. It's non-mutable. What do we mean by that? Why is that an issue? If we go back to the linked list example, if you want to use a null node, you want to add an element. One way to do it is just tell head node, add an element, and say it's a sorted list. And so the element goes to the very end. One way to be to have it go, each node tells the next one, add this, add this, add this. And when it hits a null node, it'd be nice then if the null node could add the value to itself and add another null node at the end. That does not work. Yeah, so there's we'll see this later. If you get multiple places we want to use this null object, we may want to adapter pattern. Again, in my example, it would be nice at some point we could have that tail node become a real node. So even though the null object pattern didn't make it into the Gang of Four text, it did make it into Martin Fowler's refactoring the pattern. And so there is this idea of refactoring to introduce null object. And so we want to replace that null value with a null object. And so example is, you know, we want to get the plan for a customer. You know, what happens if the customer is null? Well, we can't get it from the customer. So how can we factor this to actually get rid of this null check? So our goal is to replace this code here with that. And so we'd have a null object for a customer, which will return the basic billing plan. Otherwise, we'll get the actual plan for the customer. Right, so making very small steps. Subclass customer add is null. Add a static method in the customer to return the null customer object. And compile. And then we can, wherever we turn a new customer, instead of returning a null object, return, instead of a null, return the null object. And then all these checks go to customer is null. And we still haven't changed the basic structure. We just replaced it. Is this variable equal to null to calling is null on an object? And we can run that. Find an operation in the is null test part. We can then add a get plan method in the customer object and the object pattern, right? And the null customer just returns the basic, which we're doing over in a null check. And now we can get rid of that check and compile and test it again. Now that you're bored to tears, again, I assume everyone's made the mistake of taking a piece of code and say, oh, I need to change it here. And you start making lots of changes, and then you get lost. I've done this. It's like, okay, I'm going to change here, change here, change there, and then changes propagate, and then finally I'm ready to run it. And it's like, oh, it's not working. Why is it not working? And you try and fix this, and then this over here breaks. And when you're trying to make too many changes at once, things can go south very quickly. So the point here is, yeah, when we're refactoring code, it can be important to be able to do it in very small steps. And each point, make a small change, make sure things still work. Make another small change, make sure it still works. Any questions? Another, I don't know if you call it pattern, but it's related to the null pattern, object pattern. Instead of checking for null, there may be some special condition that you need to worry about, right? In this case, maybe there's a record is missing the customer name, or there's some unknown, right? So it's slightly different than checking for null, but we can represent these special cases by a subclass and put the special behavior there. So we can think of this, we can think of the null object pattern as a specialization of this special case, in that we have customer and null customer. So we might have, we can represent special cases with subclasses. So raise your hand if you're not confused. Okay, for some people, oh, good. At least some people are not willing to admit they're confused, right? Okay, let's go on to document 7, the observer pattern. There are some patterns which are very commonly used. And the iterator is one. Observer pattern is another one. Although how people use it has changed over the years. So the basic idea is if you have a subject and when that subject changes, you have observers that are interested in that subject. And when the subject changes, it's going to broadcast that change to all its observers, and the observers will update themselves. Some of you know the MVC pattern or model view controller pattern. You know, that uses the observer pattern usually to broadcast changes from the model to observer. So the basic idea is we have some subject that has contains some data. And when we change that data, we trigger a broadcast mechanism, and we then tell each person has registered to observe us that I've changed, and then they get the new value from the observer, from the subject, and then do what's appropriate for that particular observer. You know, so the way it operates is, you know, there's some method, the subject will change one of its fields or multiple fields. In the Java world, then we then call notify in the subject, and that triggers an update message to be sent to each one of the observers. And the structure is, right, there's some interface which tells us what a subject needs, usually the way of adding observers and subtracting observers. And then we subclass that to get a concrete subject. There's also some interface for the observer, so the observers implement. Right. And one thing to note is in the Java world, when internally a subject that calls notify, that is just that method has a loop. It goes, goes through all observers and say update, 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 which means, right, until all the observers have been updated, we're still in that notify method. And that we'll see that becomes important later. So far, so good. So one example of this is in Java, or you're an Android programmer, there's these on-click listeners. And so you then, right, the interface is, on click. And then you can register, be notified when that the events occurred. All right, so here's a Android example where I have this. I'm going to observe this button, and when the button state changes, when someone presses on the button, the button will then will broadcast a change to everyone who's registered to be an observer of that button, and they then call on click. So they didn't use update, they use on click to be more expressive in this particular circumstance. Sort of a fake Java example. I created some fake class I just called a subject. And there's some method that changes my state. I then need, my subject needs to, right, have a way of doing various things. I've got a, change method. So what I'm going to do now is when my state's changed, I call changed, I'm going to get all my observers, have an iterator, and then each time I call update, and then my update method, right, is going to get the subject from my subject and do something with it. The basic idea is you have your subject has a list of observers, and when your state changes, you go through the observers and you call whatever method your observer pattern has decreed, in this case, update. Yeah, so there are a couple of important things with the observer pattern. One is we decouple the subject and observer. Right, in this case, right, I have to know my observer, and I'm calling methods directly on my observer, in this case a window. And if not, I want a different type of object to observe my subject, I can't. in the second example here, right, my subject doesn't know the type of object that I'm dealing with. It just knows I have a list of observers, and when I change, I'm going to call update on them. So my subject has no idea the concrete class of my observers, how many I've got. So it decouples my subject from the observers. Now, the observer usually has to know details of the subject to get the right values out. And updates can take too long. What does that mean? Look, if I've got 50 observers, I'm cycling through each observer and calling update on each observer. What does the update method do in that observer? If it does a lot of work, it's going to take me some time to cycle through all 50 of them. So when I call changed up here, if there's 50 of them, that while loop will take a while. And so the program is just sitting here waiting for all those updates to take place. And since I put the slate method, it will take a while, right? There's a time when basically every language that came out in the class library had direct support in the library for the deliver pattern. In Java, there was observer and observable. And so there's the observable had various methods defined for us. But in Java 9, they deprecated this. You have to keep in mind that design patterns started in the early 90s, and Java came out in 1995. So I'm assuming that in many cases that predates when you were born. And so the world has changed a bit in different ways. So what Java has done is they replaced the observer and observable with what they call reactive streams, flow. And flow has a number of different pieces. One is there's a publisher, which takes the place of the subject. There's a subscriber, which takes the place of the observer.
Professor, you're on mute.
Did everyone lose a connection or just me?
I think it was just you. Though some people did disconnect as well, but I think the majority of us did not.
That now I need to share my screen again. definitely not. Okay, share the screen. And now we get to rearrange everything. And now I need chat. It would be interesting problem would be to figure out where the problem was, right? Is it, if it was just me, then it could be my network connection. If it was multiple people, it could have been a connection on a server. Anyway, before things went blank for me, I was talking up to Flow, which replaces the observer.
Sorry, can you go back a tiny bit to like to talk about Java Beans and then the flow? I think you were like kind of just starting the slide.
Yeah, so observer and observable have been deprecated in Java 9. I haven't checked. I believe Java 15 just came out. I haven't checked to see if it's still there or not. For a long time, Java would deprecate things, but they wouldn't delete it. So there were things which were deprecated and stayed in the JDK for 20 years. But at any rate, if they're deprecated, it's not a good time to start using that feature unless you're using Java 8. So they've been replaced, right? And they use Java Beans and what they call reactive streams. The package is called Flow, and Flow has a publisher, which is used to, like a subject, so it will produce changes or data. Subscribers are sort of like observers. You have a processor, which acts like both, and then a subscription is sort of a link between a publisher and a subscriber. But the system is more general, and it follows yeah, that's true. All right, there's a couples. So we'll look at some of this a little bit later, but it's important to know that this is in Java world, this is going away, right? So the classic observer pattern, right, was good. Subject knows both the observer interface, but it doesn't know the concrete type, right? How do the subjects keep track of observers? Usually there's just a list of observers. It could be that observers observe more than one subject. If that's the case, how does it know when it gets update method? Which one was sending the update message? In the Java world, in Java 8, we can then send in data inside the update message to specify more information. As always, if we're doing observer pattern in C++, you have to worry about memory management And since the subject has a pointer to an observer, and vice versa, it's complicated, but you have to make sure that when you keep track of which one's deleted, the observer has a reference to a subject, and the subject is never going to go away, and vice versa. Who triggers the update? In Java, trigger an update in a subject was a two-step process. One was set changed. That set a flag in the subject saying that some change has been made, and then notify observers is it would cause the update message to be sent. Right, so here I'm having the subject itself trigger the update message. We could also have the clients call notify by again having, calling budget increases and then call notify observers. So who triggers the update? Well, it could be the subject or it could be the client. One issue is, making sure your subject is consistent. So here I've got a parent class that does some wacky things, right? So it makes several changes and states, and then it calls notify observers that say I'm okay, right? Now I've changed, you get updated. I create a subclass, and I'm going to call, right, this tricky change. Now the problem is when I call super tricky change, it's going to trigger a broadcast to all the observers, but I'm not done yet, right? The subclass is going to do some more work. So the subclass is not ready to be observed yet because it's in the middle of the change. So that could be a problem. So the issue here is we want to make sure that the subject is, all the changes are done, and now we can let the outside world know, now you should update yourself. Clear, not clear? When we read the text, I'll talk about a change manager, something to manage all the changes. So the changes get very complicated and there's many steps, right? You may need to wait until the very last step is done before you broadcast a change. So we'll need something to sort of keep track of all those changes and know when they're done. This set changed and notify observers is where they tried to do that in Java. So we could do multiple changes and then later we could say, okay, now do the broadcast. Adding information about the change. So in Java 8, your update message could send two objects to the update message. One is we can send the object which actually changed, and we can also send some message. And so here I'm just passing a message that the message can receive. Right, so we get the update method does not have to be just update, but we can pass data in it, which the observer can deal with. Or we can just always have the observer ask the subject what's changed. That gets a bit trickier, and I've never actually seen that. Most implementations of observer pattern I've seen don't use a pull model, use a push model where the subject pushes information to the observer, and then the observer looks at that to react to it. So even though text talks about the pull model, I've not seen that implemented. Like I've indicated several times, if you get many observers, when you send a broadcast out, you have to wait until they're all updated, and that can take a long time. And this actually, the major problem when Java first came out, when you built a GUI, they used the observer pattern, and whenever any change occurred, it went to all the widgets on the screen, and it was really slow. All right, so what to do when the subject changes too fast and you can't keep up? There are several things which people did. Like I said, when Java first came out, your subject broadcast changes to all the widgets, even if the widgets didn't care about that subject. And so what they did is they they broke it down into different types of listeners, different types of subjects. So they created different type of events, different type of listeners. And so you'd only broadcast the updates to things that needed it. Another way of dealing with it is you make your subject smaller and smaller, so there'd only be fewer observers of it. In visual small talk, basically a subject was just a single value, so it's a single number or a single string. And that got rid of this problem because you're not going to like too many observers on a single number as opposed to having an observer on a larger class. So far, so good. Now, a related topic, reactive programming. Software is becoming very complicated. It's embedded everywhere. Software needs to be more robust because it's embedded everywhere. Have to change faster. And so this idea of reactive systems that are more responsive, more resilient to failure, easier to react to more loads, and are message driven. And you know, when you go on the web these days, some of these websites, I mean, Google, Facebook, Twitter, right? Amazon, those systems have to respond to huge number of requests and respond very quickly and can deal with huge amounts of data, right? And so this idea of reactive programming, again, is relatively, well, depending upon your perspective, either relatively new or not so new. 1997, the idea of reactive functional programming. 12 years later, this actor model came out, reactive streams. Same year, Microsoft came out with their reactive extension for .NET. And 2 years later, it became official. 8 years ago, this thing called Elm came out, which is functional programming for the web. It never caught on big in the web world, but it did gain, lots of people were very interested in it, and all the alpha geeks were like, oh, this is amazing. 2013, Facebook comes out with React. Why? Because their applications and the web application they had was getting so complicated and so convoluted that the engineers at Microsoft were having a hard time maintaining it. 6 years ago, people ported Microsoft's ReactiveX to Java. 5 years ago, Flutter came out, which was a reactive system. 4 years ago, second version of RX Java. Flutter came out 2 years ago, official version. Last year, both iOS and Android came out with beta versions of doing reactive programming for iOS and Android. So and by now, most of the major web frameworks have a reactive component to it. So reactive programming is basically taking over, or in the process of taking over, mobile applications and web applications. And ReactiveX, right, so they claim that ReactiveX does the observer pattern, the iterator pattern, and parts of functional programming. And Java's flow is basically heavily influenced by ReactiveX. And ReactiveX has been ported to multiple languages these days. Syntax will vary. To give you an idea of what we mean by reactive programming, spreadsheets are the one thing that everyone talks about as an example of reactive programming. When I got a spreadsheet, what do? Well, you say, cell A is going to be cell B plus 5, right? And when cell B changes, A changes automatically. We don't say, when we change cell B, we don't say, oh, we don't have another statement saying, now go change, right, cell A. We just say, no, we just say cell A depends upon cell B, and when B changes, A is updated automatically, and all the cells depending on cell A on B are updated automatically when cell B changes, and those cells are updated, they will broadcast a change to all the ones observing them, right? So we can think of a spreadsheet as a, an example of observer pattern where cells observe other cells, and when a cell changes, all that is broadcast. There's also an example of reactive programming. The cells react to changes in other cells. Right, so when I change the value of this cell, all the cells that depend upon it are changed automatically, and those changes are broadcast. Right? And when we set this up, we don't say, when I've changed broadcast, we just say cell A is cell B plus 5, right? This is sort of everyone's classic example of reactive programming. We're not specifying what to do after the change, we're specifying the dependencies. So spreadsheets example, Elm's example, and React from Facebook. Reagent is built on top of React. Android has their architecture components, which are reactive, Swift UI now, Swift Combine, Flutter from Google. Fuchsia is Google's third operating system we're developing. It's all reactive. So there are a lot of systems out there. Java Flow is reactive, and ReactiveX. So reactive programming is becoming, it's growing. It's something you should know as a graduate student in computer science. And it does change how you build applications. The way you build applications in Swift UI is completely different than you did before Swift UI. Android architecture components change the way we structure the application. Elm, here's a demo of Elm. Where as I move the mouse around, it's just printing out where the location of the mouse. And the entire program is, I need to use a different color. So I'm gonna use this color, right? This is the entire program. The mouse position just gives you the current value of the mouse. Right, so where's the mouse? As text, takes that mouse position and converts to text. Lift transforms from a single value to a stream of values. So it's saying, give me, whenever the mouse position changes, give me that update, right? So in one line of text, we wrote a program which, tracked the mouse and printed it out. And it's hard to get a smaller program. Hart, you have a question?
Yeah, I'm wondering how expensive this is. Is the CPU checking this observer every cycle, or how does that work?
Yeah, so the question is, are we in an event loop checking everything? I don't know how it works in Elm. I haven't looked in the details. But in Java Flow and ReactiveX, the answer would be no. We're not in a loop checking for events. We're waiting for an event to be triggered. So it's probably the same thing here, right? The operating system is going to, inform the system that mouse change is changed. But generally, you don't want that, right? We don't want to have a tight event loop trying to check for changes. That is very time consuming. That can consume a lot of CPU cycles. Here is a SwiftUI example. Again, what I want to point out is I have a field or property in their struct. I have a button, and I give a button a lambda, and that lambda changes the value of count. What we're not doing is we are not then saying, now go update the text which displays on the screen. We're just saying change the count. And the same thing with this button, we decrease the value. And then the text I'm displaying down here is just using count. So when we click on one of these buttons, plus or minus, right? What's happening, the button is going to update the count. And then anything on the screen that depends upon count will be updated for us automatically. So it really, we do two things. We specify code that update state, and we also, the second thing we do is we say, here are dependencies on the state. We don't do things like, oh, first go change count and now update the display. And that makes the programming a lot easier. An example this small, it won't matter. But when you start getting complicated situations, right, it reduces the complexity because now we've got state, we've got things that change state. And when we change state, we don't have to worry about who's observing the state, who's using the state. Over here, we've got things that use state, and they're going to be updated automatically for us. Now, what's going on behind the scene is, this annotation basically converts this count integer into a subject in the observer pattern. And, behind the scenes, anytime we use count, that becomes a observer of that subject. And so the compiler is doing the work for us, but allows us to focus in on, have fewer details to worry about. And this is why Facebook started React. The problem was, look, on your feed, you've got all your friends and your multiple friends, and they're updating, they're inputting different things. You've got the ad feed, you got the news feed, and so when they're basically pulling things off the server, and I get this ad feed, I have to put it here, and now I get this thing and put it there, and there are so many dependencies and so many updates that are happening. Things are all of a sudden the screen was, they were inserting a new ad here, but things were getting pushed down. And by hiding all this in reactive programming, where we can just say, look, we're going to build a system that allows us to update state, and then the screen is going to magically, or not magically, it's basically observer pattern behind the scenes, update the observers for us. It simplifies their work. So this is like I said, reactive programming is up and coming. Once you conquer the web world, or people think you've conquered the web world, and you're now in the process of conquering mobile computing, it gets to be a big chunk of what people do these days. We made it through without too many problems. And we're out of time, so presumably there might be a few questions in assignment 2 next week. So we'll see everyone on Tuesday.
Thank you, brother.
Thank you. Have a good night.
Thank you.
Thank you.
Thank you.